Over 60% of home bakers report that their baked goods fail at least once a month. Not because they used bad ingredients. Not because their oven was broken. But because they changed a measurement by just a fraction. A single extra tablespoon of flour. Half a teaspoon less of baking soda. That is all it takes to turn a perfect cake into a dense, flat disappointment. Baking does not forgive guesswork. And once you understand why, you will never eyeball a recipe again. Tease in the next 10 minutes, we are going to pull back the curtain on the real science happening inside your oven. You will learn why baking is fundamentally different from every other kind of cooking, what chemical reactions are triggered the moment you mix your ingredients, and why professional pastry chefs treat their kitchen like a laboratory. We will also reveal the one ingredient that most home bakers completely misunderstand, and getting it wrong is responsible for more failed recipes than anything else in the kitchen. Background baking is one of the oldest food preparation methods in human history, dating back at least 14,000 years. Archaeologists discovered evidence of flatbread baking in what is now Jordan, made from wild cereals ground into a crude flour. But even those ancient bakers understood something instinctively that modern home cooks often forget. The ratios matter. The process matters. Baking is not cooking. Cooking is improvisational. You can add a pinch more salt, swap one vegetable for another, adjust the heat on the fly. The dish responds to your instincts. Baking does not. Baking is chemistry. And chemistry has rules. The word baking itself comes from the Old English word bacan, meaning to cook by dry heat. But what actually happens in that dry heat is anything but simple. Heat triggers a cascade of chemical and physical transformations involving proteins, starches, fats, gases, and water. Every single ingredient in a baked good has a specific scientific job to do. When the balance is off, even by a small margin, the entire system can collapse. This is not metaphor. This is molecular reality. Main content. Let us start with flour, because flour is the foundation of almost every baked good. Flour contains two proteins called glutenin and gliadin. When you add water and mix, these proteins bond together to form gluten, a stretchy network that gives bread its chew-in structure. But here is the critical part: the amount of gluten you develop depends directly on how much flour you use and how long you mix. Too much flour creates too much gluten. Your cake becomes tough and dense. Too little flour and there is not enough structure to hold the rise. The whole thing collapses. Professional bakers weigh their flour in grams rather than measuring by volume precisely because a cup of flour can vary by up to 20% depending on how tightly it is packed. Now consider leavening agents. Baking soda is pure sodium bicarbonate. It is a base. When it comes into contact with an acid in your batter, buttermilk, vinegar, lemon juice, brown sugar, it produces carbon dioxide gas. Those bubbles get trapped in the gluten network and push the batter upward as it bakes. The math is unforgiving. 1/4 teaspoon of baking soda per cup of flour is the standard ratio. Use more and you get a metallic, soapy taste. Use less and your baked good sits flat. There is almost no margin for error. Baking powder is different. It contains both an acid and a base already combined, plus a starch to keep them dry and separate until they hit moisture and heat. Most modern baking powder is double-acting, meaning it releases gas twice, once when wet and once again in the oven. This gives bakers a small window of forgiveness. But even with baking powder, the ratio still matters. Too much baking powder and the bubbles grow too large, rise too fast, and then collapse before the structure has set. You end up with a sunken center. This is not opinion. This is gas pressure physics. But here's what nobody talks about when it comes to baking failure. Eggs are the most misunderstood ingredient in the entire process. Most people think eggs are just there for richness or color. They are not. Eggs are doing at least 4 different jobs simultaneously. The yolk provides fat, which coats gluten strands and keeps them from overdeveloping, giving you tenderness. The yolk also contains lecithin, an emulsifier that holds fat and water together in a stable mixture. The white is mostly protein and water. When heated, the egg white proteins denature and coagulate, meaning they unfold and link together, providing structure. The water in the egg turns to steam, providing additional lift. Remove one egg from a recipe that calls for 3, and you have disrupted the fat balance, the emulsification, the structure, and the steam production all at once. Mid-roll break sugar is another element that bakers routinely underestimate. Sugar is not just sweet. In baking, sugar is a tenderizer. It competes with flour proteins for water molecules, which limits gluten development. It raises the temperature at which starches gelatinize, keeping your baked good moist longer. And through the Maillard reaction, which begins around 150 degrees Celsius, sugar reacts with amino acids to produce hundreds of new flavor compounds and that golden brown crust everyone loves. Reduce the sugar and you get less tenderness, a paler crust, and significantly less flavor complexity. It is one ingredient doing the work of 4. Fat, whether butter, oil, or shortening, functions as a lubricant and a moisture trap. Butter is 70 to 80% fat, with the remainder being water and milk solids. When creamed with sugar, butter traps air, creating a foam that gives cakes their light texture. The water in butter also produces steam in the oven, contributing to rise. Oil, by contrast, is 100% fat with no water. This is why oil-based cakes are moister but denser than butter-based cakes. Swapping one for the other is not a simple substitution. The entire moisture and aeration chemistry changes. Deep dive temperature is where amateur bakers most consistently go wrong, and the science is precise. Butter that is too cold will not cream properly. Butter that is too warm melts before it can trap air. The ideal temperature for creaming butter is around 18 degrees Celsius, slightly cooler than room temperature. Eggs and dairy that are too cold will cause the butter to seize up and separate when added, breaking the emulsion. This is why professional recipes specify room temperature eggs and milk. It is not aesthetic preference. It is emulsion chemistry. Oven temperature calibration is equally critical. Studies have found that up to 70% of home ovens run at least 15 to 25 degrees off from their displayed temperature. A recipe that calls for 175 degrees Celsius is calibrated for that exact heat. Too hot and the outside sets before the center has risen. Too cool and the leavening exhausts itself before the proteins and starches have set. The bake collapses. An oven thermometer is not optional equipment for serious baking. It is a basic scientific instrument. Analysis. What does all of this mean in practical terms? It means that when a recipe fails, the answer is almost never in the quality of the ingredients. It is in the ratios, the temperatures, and the technique. Professional pastry chefs do not taste as they go. They measure, they calibrate, and they repeat the same process with discipline. The world's best bakeries run like laboratories, with digital scales accurate to 1 gram, temperature-controlled proofing chambers, and standardized mixing times measured in seconds. The broader implication is that baking rewards patience and precision in a way that no other culinary skill does. It is a skill that builds scientific literacy, attention to detail, and an understanding of how matter transforms under heat and pressure. When you understand the why behind each ingredient, baking stops being intimidating and becomes deeply logical. Every failure becomes data. Every success becomes repeatable. Conclusion. So here is what we know. Flour builds structure through gluten. Leavening agents create gas that lifts. Eggs provide structure, fat, emulsification, and steam. Sugar tenderizes, browns, and flavors. Fat lubricates and aerates. Temperature controls every single reaction. Before you go, if you learned something valuable today, hit that like button right now. Subscribe to Flavor Vault for a brand new video every single day. We will see you in the next one.